So with the amazing cell, we talked about the cell that was before nucleus. It's it's almost a remnant of a bacteria. What was the term for this cell that was before the nucleus? A prokaryote. Pro meaning before, karyote meaning nucleus. Now, what was the more complex cell that did have a nucleus? What was it? The eukaryote. And we discussed that the prokaryote, being more of a bacteria than a cell really, ended up being engulfed by the eukaryote and ended up becoming part of the eukaryote, providing it with the energy, becoming what we now know today as the mitochondria. Very nice. Oh, let me get in here. All right, we started talking about the cell membrane. The plasma membrane is what it's also sometimes known as. And this cell membrane is made up of a phospholipid bilayer. It's like the skin of the cell, and it separates it from the environment. The cytoplasm is everything inside, including the nucleus and excluding the nucleus and the genetic material. And then our nucleus, which is kind of the brain of the cell, this is where we're going to find that genetic material. Here was the cross-section of the cell. We're going to be going over each of these little components in the next section. Probably start that on tomorrow. This is all of our parts of the cell. It really is insanely complex. It has parts very similar to our anatomy. It does have things that function like kind of a GI system. It's not really using it for nutrition, using it more to get rid and digest stuff. We've got an area that functions as our liver, which is going to be these ribosomes. We have an area that functions as our kidneys, which is the smooth ER. We have a Golgi body, which functions like our circulatory system, transporting stuff around in and out of the cell. So it's really pretty amazing how our anatomy mimics that of these cells. Oh, we talked about all of this, self-repair, blah, blah, blah. No new shocking information here. All right, so our lipid bilayer, we had our heads on the outside, our tails on the inside. Heads, hydrophilic, hydrophobic. They are hydrophilic. Remember our buffalo getting into that circle when they are threatened? Their heads are on the outside and they love a fight. The tails are on the inside, hiding those that are terrified. So our hydrophobic are on the inside tails. Hydrophilic are on the outside heads. We also have little cholesterols that are wedging themselves. And these little cholesterols, they're the good kind of cholesterol. And they're going to help to stabilize and provide function and stability for our membrane. This is the structure. We talked about some of these proteins, some of these specialized proteins, like our integral proteins. A lot of this stuff that is embedded in this phospholipid bilayer really is just to regulate what goes in and out. We have some channels like selective channels, selective being just that. I am going to be very particular about what gets to go in and out of these selective channels. Pores, however, pretty much general admission. As long as you got a ticket, you can come in. Now, this pores does not mean open season for everything coming in. You still have to belong, but it's going to be a lot less judicious as far as who it lets in and out of the cell. Oof, this weather kills me. Here's my cell membrane. God, it's just so pretty. It's just so beautiful. All of this stuff happening here. It's so dynamic. Our peripheral proteins, peripheral meaning out on the side, these are going to be the proteins. Here, we can see them, peripheral proteins. There's some more. These are involved in helping the cell change its shape. It's very important that these cells have that ability, some more than others. When we draw our cell, it's two-dimensional, but we need to remember that our cells are, in fact, three-dimensional. And some of them will have to alter their shape pretty dramatically based on their job. Never mind the cells that have to shrink down in order to wriggle through the little pinholes of our blood vessels to get into the tissue. Let's take one that alters its shape pretty dramatically and we can see it. How about a muscle cell? My muscle cell, here's my muscle, starts here at my scapula. We're learning ours. See, now I know what you guys are doing in med term. Starts here at my scapula, extends all the way down here to the proximal end of my radius ulna. But look at how dramatically this muscle, it shortens by more than half and it thickens up. That is the cell's ability to change its shape because of the type of peripheral proteins that we have. We talked about cell recognition. These cells have to be able to know who belongs, who is stranger danger. This is accomplished by this outer sticky sugar coating called the glycocalyx. Glyco meaning sugar, calyx meaning coating or outer coating and covering of. The glycocalyx is kind of like your royal blue scrubs. I can look through and very quickly assess just by your royal blue scrubs that you belong here at VTI. That's like your glycocalyx. Now, obviously, our cells don't have eyeballs, and they don't have brains. They're not looking at each other. But what they are doing is kind of like a blind man touching your face. They're using this glycocalyx so when they come in direct contact with each other, they are able to identify what is supposed to be here and what is stranger danger. This is also how they are able to signal to the immune system something is amiss. So when they are detecting viruses, bacteria, antibodies, have their little wanted poster, what they're looking for specifically is this unique glycocalyx that matches whatever wanted poster they're running around looking for it. This is exactly what makes this COVID so scary. COVID has the ability to alter this identifier. So the minute that our immune system goes, okay, we got the wanted poster, you guys all keep a lookout for this guy. The minute that we have anything resembling a wanted poster, he changes it. So now if I even come up and touch him directly, I'm no longer able to identify him because he's changed his unique markers. That's pretty terrifying. He's evolved at least 4 times that we know of since probably February. That's insane. That's insanity, especially for a virus. Viruses can evolve very, very quickly, but he's evolving in the blink of an eye. Whew. He is a cheeky monkey. The glycocalyx, this is all review, guys. The glycocalyx has got our 2 families. Cell adhesion, which is going to help with signaling, also helps our cells move past each other. We talked a little bit about that tightrope. And there's another cell, and I can kind of use my stickiness to move past him. I also have this glycocalyx in cell recognition. What this is important for my immune system. So this is kind of interesting. This is where we get into a little bit of immunology. Whew, need to sit down for a minute. this guy above us, immunity grouped, immunity God, whatever you want to call it. And he's watching down over us. It is this glycocalyx that allows him to recognize what is self. Because there are some times, unfortunately, that he stops recognizing self and he thinks that everybody's a foreign invader. He attacks your own body and he kills you. That escalated quickly. Our immune system begins to think everyone is stranger danger. He sends everybody to war and then doesn't remember what side they're fighting on, and everybody gets taken out with friendly fire. That's because of his inability to see and identify these individual glycocalyx. This is important during our immune response because we don't want friendly fire. When we have an infection, we want to target the foreign invader. We don't want friendly fire because the more friendly fire we have, the less military we have to help fight that foreign invader. And that's all because of the glycocalyx that we're able to maintain our immune system. All right, so now we're on to some new information. We have this term, alveoli, which means little caves. And this is essentially how do we move stuff in and out of our cell membrane without destroying the membrane itself. So here I have something that I need to bring into the cell. The problem is if I just open this, I'm going to destroy the cell membrane. I need to be very careful not to do that. I need to keep that cell membrane intact. So what I'm going to do is I'm going to start laying down phospholipid bilayer, and I'm going to encapsulate whatever it is I'm bringing into this cell. Pinch it off right here, and you can see now I have this transport bubble, and my phospholipid bilayer is in fact intact. This is alveoli, little caves. This is how we transport larger molecules in and not disrupt the integrity of my phospholipid bilayer. Any comments, questions, concerns about that? You guys are pretty sedate again today. Have you guys done your intro lab yet? You guys, didn't you do a restraint lab?
That's next week.
Oh, I thought that's why you brought your animals with you today.
Oh yeah, we did that today.
Yeah. So here's something to wake you up. Hey, let's talk about murder for a second. This will really wake you up. You guys talked about the skeletal system today. I know you did because I talked about it with the other group. And let's sit down. My goat. All right, so you guys talked about the skeletal system. I'm determined to just break something. That's all right. The goat belongs to me. You have a bone located here in your throat that supports your voice box and the bottom part of your tongue. Does anyone remember what that bone is called? That's the hyoid bone. If you're strangling someone, that's the bone that you might break. So that automatically shows that it's murder. We don't want it to automatically show that it's murder. We want to get away with it. And so here's what we do. Not this. This. Palm of your hands on the sides of the throat on either side of the trachea. You're occluding the blood from the carotid and the jugular, the carotid artery and the jugular vein. Your victim will be unconscious within 15 seconds. They'll be dead in 2 minutes. And no broken hyoid, no bruising. It only takes a very slight amount of pressure to occlude those blood vessels. So there you go. Why am I teaching you how to murder someone? You know, it's not the first time, it won't be the last. I will be teaching you different murder techniques. Here is, oh, hands got caught. Here's why I'm telling you this. May I borrow Fluffy for a second? Oh, love him. Oh, he's very soft. So I have here my elephant, dog, cat. You guys are learning your restraint techniques. One of them, I'm not sure what Miss Cat calls it because there's 100 different names for it. I call it the yoke, which is where you use the crook of your elbow, isolate the head, bring it in towards you into the crook of your shoulder. You can either hold them like this towards you or like this towards you, depending on what you're holding off for. Okay. Does this one look familiar? I don't know what she calls it. I call it the yoke hold because of a yoke on a cattle. This is the yoke hold. Although, puppy dog doesn't want to be restrained. So I tighten my hold a little bit. Where is my arm compressing right now? Ah, what did I say would happen if you compressed right there for any length of time? Unconscious and dead. Death by restraint, it can happen. So I need you guys to really be careful and really aware of the type of pressure that you're putting on that throat. Because it'll kill them. I've never killed an animal by restraining them. I have never killed an animal by restraining them. I have seen animals die in that. Hyoid. So a little bit of murder to wake you guys up. LDL, this is just terms. I just want you to know what it means. LDL means low density protein. Low density protein will accumulate in your blood vessels. It causes them to dam up. You will stroke out. You will die. Everything is death today. I'm in a very dark mood. I am in a very dark indigo colored mood. So LDL, low density. Let's talk about cell movement for a minute. Cell movement. I have two different anatomical components to my cells that allow them to move. Typically either move things or move themselves. The first one is cilia. Cilia, if you remember from medical terminology, means hair or hair-like. Cilia reminds me of a sea anemone. Is that how we say it? Yeah, a sea anemone. They kind of do this crowd surf wave. They're going to be very short, but there's going to be a lot of them. A great example of where we see cilia is in our lungs and in our trachea. So here's what cilia is doing. Cilia is crowd surfing stuff out of your lungs. When you breathe something in and it goes down into your lungs, it's now very deep within your body. And it has access to your blood supply, which means it has access to where? Yeah, where does your blood go? Your heart, where else? Literally everywhere. Every single solitary cell in your body needs oxygen and carbon dioxide. So once something gets access to your blood, it can go anywhere in your body. When I get something like a foreign invader in my lungs, what happens is that little foreign invader, my lungs are going to start producing mucus. And this little foreign invader is like stuck in this little cage of mucus. And then what happens is my cilia crowd surf that cage of mucus, and they tickle, tickle, tickle until you cough it up, and then usually you swallow it. You do, come on, I know it's gross, but you do. You swallow it. Oh, it's a really good one. Sometimes you play with it in your mouth a little bit, like gum. Trying to wake you guys up. Come on, everyone's done that. You get a really nice, juicy one. You sit and play with it on your tongue for a little while. I call you a liar. I call you liars to your faces. Everyone's done that. Anyway, so you swallow it. Well, what we've done is we've used our cilia to crowd surf that cage of mucus. We've used the cilia to tickle, tickle, tickle. We've coughed, and then we swallow it, and that little foreign invader is now like the Wicked Witch, melting, and being killed in the vat of acid that is our stomach. Cilia, crowd surf. We also have cilia in our noses. In the sinus cavities, you guys learned about your maxillary sinuses, frontal sinuses. Inside your brain is the ethmoid sinus. These cilia, same thing. They're gonna help to signal mucus production, and they are going to crowd surf stuff, and they are going to prevent stuff from getting deep within your body. Think for a second about allergies. Let's talk about those and their role of cilia. This, I think, will help to kind of cement this idea. My body has decided that pine pollen is Ebola, and that my body should react to pine pollen just as it was Ebola. So when I breathe in pine pollen, my body automatically goes, oh my God, mucus, 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 start producing tons of mucus. Done. So it produces a ton of mucus, and these little pine pollens, although not Ebola, are now stuck. Cilia cause me to have sneezes, and the cilia, the mucus production is causing the snot, and the mucus going down the back, the postnasal drip, and all of the above associated with an allergy response. That can all be attributed to the incorrect recognition of a molecule and the cilia working together to crowd surf it out of you. Another great example is the ovaries. In the fallopian tubes, as well as in the uterus, we have these little cilia that very gently crowd surf the egg. Something a little interesting. Again, I'm just trying to get you guys to wake up a little bit. Dogs and cats have multiple babies in their litters. So their their reproductive system is a little bit different than the human. Here's the other job of, let me do this. Here's the other job of the cilia. So if I want to draw the uterus, here's an ovary, here's an ovary. Dogs and cats have very, very long uterine horns and a very short and stubby uterine body. Here's the cervix and the vagina. There are little cilia all through here. And when we release an egg, let's say the cilia, let's make the egg a different color. Here's our egg, and this egg has implanted right here. We have the corpus luteum. You'll learn all about that. Actually, I want to move this. Give me a second. What color did I use? That one. Nope, not eraser. Let's redraw that. Okay. So I have one egg implanted. Let's move it up here. As the next egg comes out, the cilia all around this egg, the cilia are activated because they know we need space between these forming babies. We can't have one being formed on top of the other one. And it is the cilia controlled by the hormones that will move the next egg in appropriate ways away so that there is enough space for both of the babies to be created. Here we have our third, and it's the cilia that would make sure that we have enough room in between the eggs for the babies to be formed. That's pretty highly intelligent considering it's not technically got any consciousness. I find that pretty interesting. Here's a picture of the cilia. So question was, when does tutoring start? So I addressed this earlier. I do tutoring and meetings by appointment only because I do have a lot of other meetings that I have to schedule. So I need to schedule you guys specifically around my other meetings. So what you need to do is email me, tell me a time and a day you are available. And that way we can kind of work something out and I will get it scheduled. But yeah, my advisement, I don't have set advisement hours. I just depend on you guys scheduling something with me, and then I do it via Zoom. Here's the cilia in the lungs. It does look kind of like a sea anemone. And you can see we're really deep within the body at this point, really down where those bronchi are. And it's going to crowd surf, and then I cough it up, and then I swallow it down. On the other hand, I have flagella. And what flagella is forward propulsion. Rather than crowd surf of the sea anemone, I have this little whip-like tail. And this whip-like tail helps the cell move in forward propulsion. One example is right here. This is a sperm. Sperm is a cell. It has a head. It has a midpiece which contains all of the energy, and then here's its tail. And it is the energy causing the tail to go in this little rotor motion that let's minimize that. To have forward motion. Here I've got another picture of a different cell right here. There's that guy. This is a little protozoal parasite. We also have another one. Have you guys ever heard of Montezuma's Revenge? You ever heard Don't Drink the Water in Mexico? Yeah, this is why. It's a protozoal parasite. He looks like this. He actually has a little happy face on the back of him. And he has a flagella. He's known as Giardia. And oh my God, he will make you wish you're dead. Giardia is no joke. I had it twice. Second time nearly killed me. So, Giardia with his flagellum. All right, you guys, what can I do to wake you guys up? Because you guys, I don't think you guys are absorbing anything I'm saying right now. Your curtains are closed. Nobody's home. The lights are on, but I don't know if anybody's comprehending the words coming out of my mouth. You're not standing up for your case right now. Okay, that works for me as long as everyone is awake. Had a doctor, here's a story that'll wake you up. Had a doctor, terrible veterinarian, terrible. I don't even know if she still practices anymore. I would never speak ill of a vet. It's not my job. I do what they tell me to do. I'm a technician. That is my job. This veterinarian was awful. So this was her, I want to say this is when she actually did get terminated. There were several incidents before this one, including setting a dog on fire. No, you heard me right. She set the dog on fire, like a blaze. That one didn't get her fired. The one that did get her fired, if I remember correctly, Beagle puppy. Cute. About 14 weeks of age, if I'm not mistaken, just at that super wiggly, I don't want you to touch me if I don't want you to touch me thing. They're in that little terrible beagle phase. If you know beagles, you know the terrible beagle phase. You're nodding, you know the beagle phase. 14, 16 weeks, they're the most destructive, they're the most stupid. They're also the most adorable. Little 14-week beagle pup came in, got dropped off for toenail trim. Owner's going to the grocery around the corner. She just dropped him off so we could hang on to him, do his toenails while she did the grocery. This veterinarian took the puppy into an exam room without any help. Thought, it's a 14-week-old puppy. I can trim this dog's toenails. No problem whatsoever. We don't know what exactly happened. She apparently over-restrained the animal to the point where it did render it unconscious. She didn't realize it was unconscious. She just kind of was in that, oh, finally stopped squirming, did you? Trim the rest of the toenails, realized that it was dead. Yeah, she killed the puppy for a toenail trim because she over-restrained it. That's not a phone call anybody wants to make. Oh, hey, you dropped your healthy puppy off for a toenail trim, which should have taken 5 seconds just to get the needles off. You want to come pick them up in a bag? So, yeah, she was terrible. She was awful. Yeah, that was the one that got her fired. Setting the dog on fire did not get her fired. Killing the puppy did. That's a great question, Mikhail. And if this is interesting you, I will tell you, and then we'll get back to this. All right, so there was a client. Now, this is many years ago. Okay, I was just at a college. I was not in a place in my career where I would question, right? Once you've been in veterinary medicine for a couple of decades, and you've worked with the same veterinarian for a very long time, it's okay to question. Hey, why are you doing that? Hey, you shouldn't prescribe that medication if you're prescribing this other medication. Where are the checks and balances? So we had this client. I was actually doing rooms. I had nothing to do with it. Had this client, like, what was her name? Ms. Fair. And she bred Grand Champion standard poodles. And the one standard poodle that she had, it was a Grand Champion, and it was a Grand Champion stud. I don't know if you guys know, this is a buku money. Boo-a-coo. She was getting anywhere around, oh my goodness, at that time, this is 20 years ago, she was probably getting 15,000 stud fee for this dog. 10 to 15. Anyway, so had a little wart. He had a little pink wart on his nose, and we're going to go buzz it off. Get a couple of other little spots that looked like they were starting up. It's nothing uncommon. It is not illegal to do on a show dog. The veterinarian at the time, a very good friend of mine, in fact, my mentor, was working with her and said, okay, well, let me go ahead and intubate. And the veterinarian said, no, don't worry about it. It'll take you longer to intubate. We're just going to buzz it. We have this electrocautery unit, and it just kind of buzzes it right off. And my mentor said, well, no, let me go ahead, because the dog is on gas anesthetic. We had gassed it and had a mask on its face. Now, gas is not 100% gas. Anyone want to guess what we mix the gas with? What does your body need in order to survive? Oxygen. Guess what the fun fact about oxygen is? It is insanely flammable. Insanely flammable. She could have killed, everybody within about a 3-block radius. So Daphne, my mentor, says, hey, No, let me intubate the animal. Because the other thing is oxygen mixed with gas makes it very heavy. So it doesn't disperse. It sinks into an invisible cloud right around the animal. And the doctor looked at her and said, no, I'm the vet. You're the tech. You're going to back up from my patient. You're going to stop arguing with me about this, and you're going to let me do my job. And Tor went and backed up about as far as she could possibly back up. The minute that electrocautery unit sparked, the entire dog was engulfed in flames. I am running rooms, doing appointments, and I smell something, and I can tell you without any shame, it smelled like the most delicious barbecue you've ever smelled in your life. I'm not kidding. I'm not kidding. Burning flesh smells like barbecue. And I go back, here I am, I'm in this little, 20-something little cock of the walk. And I go busting in the back, and I didn't know what had happened. And I go, hey, who's cooking dog back here? And meanwhile, they have a towel, and they're beating this animal's head, trying to get the flames out. Oh, gee whiz. If that flame had gotten up into the, kind of backflashed into the oxygen of the anesthetic machine and into the oxygen tank, the little H tank that we have, that would now have been a bomb. Small tank would have taken out probably at least 3 square blocks. Completely obliterated. This poor animal, because its head was on fire, it inhaled the flame. That's the most dangerous thing about fire, It's not you getting burned, it's you inhaling it and cooking you from the inside. So he had massive lung damage, massive tracheal damage, burned all of the cilia. Can't crowd surf any more foreign invaders. The black standard poodle. What color does scar tissue grow back? Pink. He's a black grand champion standard poodle. Not anymore. So yeah, so that happened. Well, the owner at first was very upset, of course. We treated the animal. The animal was in our care because we were kind of a sort of an emergency facility. We had extended hours. We kept the animal and transported him back and forth from the EC for probably a good 3 weeks at no charge, obviously, at no charge. She was going to sue, and she would have won a crap ton of money because, well, you know why, because. So basically, she was a good friend of the owner of the practice, and she'd been following him around for years and years and years and years and years. And he basically told her that for the rest of her life, not the dog, the rest of her life, she would never again pay for a veterinary fee. She had 7 other standard poodles. And so any dog that she had at the time or would have in the future, everything was free. From heartworm preventative to vaccines, food, everything free for the rest of her life. And she agreed not to sue, and the doctor did not get fired until she killed the puppy, and then she did get fired. So there are some bad vets out there, guys. I hate to say it, there are some bad vets. Luckily, she is the only truly horrific vet I've ever worked with. Every other vet I've ever had the pleasure of working with has been absolutely wonderful to learn from. All right. Let me find, I have a quick video that I wanted to show you that kind of does an overview of what we're doing next, which is going to be all of the parts of the cell. This video is on my website. I don't have any of this on Moodle because I'm frustrated with Moodle right now. Here we go. All right, so this is called a tour of the cell. Can you guys in TV land, can you see my desktop right now? Are you seeing